Okay, hi everyone. This will be an annotated diagram showing what happens at the convergent plate boundary between an oceanic and continental crusts. Now for this especially, you need to be able to show the distinction between oceanic and continental because it shows your conceptual familiarity. For instance, oceanic crust is thin, continental crust is thick, and oceanic crust will be the denser one, so it will confirm subduct under the continental crust. Okay, knowing all this in mind, you also need to be familiar with what's the outcome. In this case, there will be a trench, a volcano, and a fold mountain. So when you draw it, it has to already be featured. So let's begin. This is my oceanic crust. As you can see, this is the one that will be subducting, and it is relatively thin because I'm going to compare it to a really big, fat, thick continental crust. Okay, so I will label, nevertheless, to make sure that it is clear to my reader: oceanic crust, continental crust. Okay, now in our explanation, let me once again draw this. This is the sea level. Okay. Again, in our explanation, please make sure we label the processes, and it will always begin with convection current in the mantle. Convection current in the mantle pulls two plates together. Yeah, the word together will help to indicate that this is a convergent plate boundary. So for this, there will be a compression force. Now this compression force will result in subduction, so you should label it subduction of the denser oceanic crust due to compression force. Yes, and this will form a trench. Trench formed at point of subduction. Okay, I hope you notice that there are lines and arrows here. Arrows indicate direction, compression force, convection current, subduction. Lines, on the other hand, indicate labels. Okay, so we are already at step 2 where there is subduction. Now, as a result of this subduction, there will be the formation of magma. Step 3, as crust subducts, it melts under high temperature and pressure, if you want to say it, in the mantle. Okay, forming magma. It's still magma, haven't become lava yet because it hasn't reached the Earth's surface. Now this one, it will move up. Okay, now this process is the one that results in the formation of a volcano. So I would label this as, I will annotate the process saying that as magma rises through the cracks on the continental crust, it solidifies and builds up, forming volcano. Keep in mind, while this is a single volcano in a 2-dimensional diagram, in a 3D diagram, if that were ever shown in an exam setting or otherwise, you will realize that there's a lot of volcano. It doesn't just exist as a single one. Okay, now if you notice this in the background here, there are a lot of waves. The reason being, step 5. Okay, on top of the convergent boundary that happens between two oceanic crusts, which forms almost exactly the same thing, this has an additional bonus of a fold mountain, which is, the explanation is the same thing as any other fold mountain: compression force causes the continental crust to buckle and fold upward. Okay, this one will be a fold mountain. apologize if it is a bit untidy over here. It's not enough space right now, but in an exam setting, please be wary of what you're drawing. So these are the various steps that should feature inside your answer. It should already show a trench, a volcano, and a foam mountain, because these are the three things that will happen as an outcome. Now, this is an annotated process. If the question is asking you to draw a labeled diagram, this should suffice with everything that happens just now, step 1 to step 5, written as a paragraph below, to explain the process.